2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020 CD3, are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. The movement of galaxies and clusters billions of light years away from us suggests there's some enormously massive body outside the visible universe. After billions of years, the expansion of the universe will make the space so sparse that we won't be able to see the stars in the sky at all. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot. Saturn is mostly composed of hydrogen and helium, with some traces of methane, ammonia, and water. But it contains more sulfur than Jupiter, which gives the planet a smog-like orange hue. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles. So, depending on where you are, sound waves can be possible. Astronomers know for sure that the universe is growing bigger, and the speed at which it's ballooning is increasing all the time. But if the whole thing is swelling into something bigger, then it must have some kind of an edge, right? It's unlikely that people will ever find out, but if so, then what would it be? A ginormous brick wall and then nothing? An abyss that leads to nowhere? The most common theory is that the universe is shaped in such a way that it can't have an edge. But it's not the only idea. Another theory is even more difficult to comprehend. The universe is, indeed, infinite, and our part of it isn't that unique. It means that somewhere out there, there's another you, or rather, other you. One of them is just a bit shorter, another wears their hair in a different way, and the third one is identical to you in all possible ways. There's also a theory about a multi-universe that consists of many smaller universes, and the universe we live in is just a tiny bubble among other similar bubbles. Those scientists who support this idea are also sure that bubble universes can come into contact with one another. Then gravity starts to flow between them, and when 2 or 3 universes connect, a big bang occurs, just like the one that created our home universe. Neptune is the windiest place in the solar system. Clouds of frozen methane are whipped across the planet at a speed of 1,200 miles per hour. Neptune's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times bigger than that of Earth. The temperature inside reaches 9,000 degrees Fahrenheit. Astronomers also believe that at a depth of 4,500 miles, there might be a diamond layer where it's raining diamond crystals. On Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish red sky turns blue as the sun goes down under the horizon. It's because Mars is much farther away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. At around a quarter of the size of Earth, the Moon is pretty enormous relative to other satellites out in space. There's nothing quite like this situation anywhere else in the solar system. Pluto has a moon that's almost half as big as itself, but it's more like a twin than a satellite. There are more than 150 moons in our solar system, and Earth's is the 5th largest out of the whole lot. There might be a labyrinth of lava tubes on the moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface. About 30 miles long and 60 miles wide, the cave's likely to be the result of 3-billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the moon's surface discovered by NASA might be the openings to lava tubes. We can't dig up most of Earth's gold. 99% of it ended up in the center of the planet several billion years ago, attracted by the iron in Earth's core. We're talking about 1.6 quadrillion tons of gold here. That's enough to coat the entire planet's surface in 1.5 feet of the stuff. And if all those meteorites hadn't later smashed into the ground, bringing extra amounts of gold, it would be even rarer. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden underneath the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared on the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in the Earth's oceans. It's one of the oldest, largest, and, at more than 12 billion light-years away, one of the farthest things known to humankind. Astronauts in space can lose about 1% of their muscle mass each month. To prevent this, they have to stick to an exercise regimen that lasts 2 hours every single day. The Milky Way galaxy and the Andromeda galaxy are going to meet in 3.75 billion years. They're moving toward each other at a breakneck speed. When the two galaxies collide, they'll form a huge elliptical galaxy. I won't be around then. Have you ever looked up at the night sky and tried to count all the stars? Yeah, good luck. Our galaxy, the Milky Way, has about 100 billion stars, but other estimates put it at over 200 billion, since calculating the exact amount is an almost impossible task, even for astronomers. As for the entire universe, there are at least 1 billion trillion stars. That's one with 21 zeros after it. For comparison, that means there are more stars in space than there are grains of sand on all of the Earth's beaches.
Behold the distant future. Yep, humans have successfully colonized Mars and the Moon. Problems with overpopulation and hunger on Earth are solved. But soon, a new threat looms over our planets, and the Moon. Anyway, scientists have figured out that in 150 years, the Sun will explode and destroy our entire solar system. Bummer. There's enough time to build a fleet of huge spaceships and evacuate everyone, but it's not enough time to come up with some sort of sci-fi space jump. It's been a long time since people found a new, potentially livable planet, and the nearest one's a several million years ride away. There's no other choice. Humankind is evacuated into gargantuan spaceships, and the infinitely long voyage begins. A few decades pass. We leave the solar system and watch our sun explode. A huge flash and that's it. There's no more light. Just small, faraway stars and the infinite black depths of space. All ships are on a synced autopilot that won't go off course no matter what. Even if everyone on board were to disappear, the ship would still arrive at its destination. So, the upside, humans will survive for millions more years. The downside? Because of all of that time spent on space transports will look different, totally different. Ships arriving to the new planet will be populated with shapeless, pulsating biomasses sitting inside metal exoskeletons. Here's how it happens. Bones in space get weaker, so do muscles. There's no gravity, so your body's not under any sort of pressure to keep it running properly. Astronauts on the International Space Station do a lot of exercise to stop their muscles from withering away. Back to the story. There are gyms and special machines that recreate gravity on every space transport. But to save energy, they're only plugged in a couple of hours per day. Unfortunately, no matter how hard people exercise, in space it just won't be enough. After the first 100 years, human bones have become so brittle that anything remotely physical can lead to injury. After another 100 years, people lose the ability to stand up on their two legs, but it's not only because of weak bones. After all those years in zero gravity, the human body's already changed a lot. A big problem is that people lose their sense of balance. If you try to stand up, you'll just fall. The ship's captains dismantled the gravity machines. They weren't working anyways. And all the sports equipment on board got taken apart ages ago and used as spare parts for the ships. The lack of gravity didn't just make people weaker, it also made them taller. The spine needs gravity to keep it stable, and now all those backbone discs have stretched themselves out. Humans are starting to look like blow-up toys. Everyone's given mechanical arms and legs. You just strap them on and get to work. Servicing the engine, cleaning out the bedrooms, throwing trash out into space, lifting anything. Not happening without those mechanical arms and legs. Time passes and people become more helpless. Luckily, the mechanical bodysuits keep getting better and better. Since the sun collapsed in on itself, human eyes have been having a hard time. Inside the ships, the sun is replaced by special artificial light that also gives off vitamin D. Since there's way less light overall, people's pupils become whiter. Then after a few more centuries, their vision really starts going downhill. But this problem is solved by technology. Artificial lenses magnify light and keep humans from going completely blind. The ships get disinfected every single day. That stops bacteria and microbes from multiplying. But it also means that the human immune system doesn't have to fight off any diseases. Pretty soon, humans can't defend themselves against anything. Even a mild cold could be seriously harmful. It's fine for now. There are no germs or anything on board. But what's going to happen later on down the road? On the ship, millions of plants grow in special greenhouses with water and ultraviolet light. The plants produce oxygen and spread it through the entire ship. Of course, it's not enough oxygen to satisfy millions, but it helps people remember the planet they left behind. After centuries of living on spaceships, humans have adapted to the new conditions and almost stopped breathing. Lungs have disappeared almost completely, and humans are starting to develop other ways of getting oxygen. From water, from liquid oxygen tanks, we're becoming a totally new species. But it's not all bad. Genetic engineering is developing every year. Full-fledged life support suits are created. They help with movement, strength, speed, vision, hearing, even speech. People's voices get so weak they can only speak in whispers. Luckily, the suits have built-in microphones and speakers. There's no food anymore, just specially created liquids. After all that time in space, the human stomach can't digest anything anyway. Fancy a handful of peanuts or a small cracker? Forget it! In the beginning, the special space food had loads of flavor. But over time, people sort of forgot what things were supposed to taste like. Eventually, they stopped adding in flavorings, and because of this new tasteless food, tongue receptors stopped working. Soon, people lost all sense of taste. For some people, this life seems unbearable, but they have a choice. They can just slide on into a cryogenic capsule for millions of years. Then it's just a matter of a quick defrost when the ships finally arrive. But it's seriously risky to be frozen for such a long time. There's no guarantee that the ships won't crash into a huge meteorite, or worse. People start to take a different approach. They upload their consciousness to a central computer. It's safer and requires much less power. And when you wake up, you can just download your mind into a new, modified human suit. Some people decide to stay awake and live a, quote, normal life. Thousands of years pass, then millions. Humans look really different now. All their limbs are now artificial, and the exoskeletons they wear are controlled by mind power. With each passing millennium, arms, neck, legs, and spines, they become smaller and smaller. Brittle bones soon dissolve into nothingness. Eyes, nose, and mouths disappear. The brain isn't protected by a skull anymore, it's just surrounded by soft skin. Only consciousness remains. Nowadays, a human is a powerful high-tech robot ruled over by a small pulsating bag filled with a brain. It's been a few million years since humans left Earth. All the ship's inhabitants have already forgotten that their species was born on a planet with gravity. The history of life on Earth has become a myth, an ancient legend. Most people believe that these ships are their true homes, always have been. That's why, when humans finally reach their destination, no one's that eager to get off and have a walk around. Life on a new, unknown planet seems like a huge pain in the spacesuit. Gravity, air, bacteria, germs – it takes several thousand years of evolution for humanity to get used to these new conditions. Luckily, humans have a secret weapon – technology. At this point, all humans are downloaded from the central computer into new robot suits. People face a choice: get off the ship and make this planet their new home, or stay and live on the ships. Those that stay on the ships set off into the expanses of space to explore the galaxy and discover new worlds. Those who decide to stay on the new planet have to adapt to the new conditions. It's pretty different from Earth. There's a different air density, different weather patterns, and strange new chemical elements. It will take another million years before these robo-brain sacks take on a new shape. One day, these distant human descendants will want to research their origins. They'll invent a ship that can jump through space and time. The research will lead them to the distant past, to the small planet Earth, to now. This might sound crazy, but just imagine that tomorrow someone lands in your backyard and they're your descendants from the future. Those passengers who stayed on the ships will probably find new planets and maybe decide to stay on some of them. Their bodies will change and adapt too. So, in billions of years, the universe will be inhabited by different amazing creatures that all have something in common. They were all humans once. You are waiting for your garlic bread in the oven. While looking up at the stars through your kitchen window, you ask yourself, could you send garlic bread to space? And more importantly, could you still eat it if it came back? Some mighty important questions. Usually, when it comes to garlic bread, there are only two things people care about. Do we want cheese on it? And, oh yeah, eating it. That mouth-watering garlicky taste combined with the soft warm bread. Okay, focus. How are we going to send the bread to space? Given that NASA's first space shuttle cost roughly $49 billion, I don't think they'll allow us to borrow a rocket ship for the day, since they may have, more important things to do. I know, it's hard to believe that some people don't take garlic bread as seriously as the rest of us. Don't worry though, all we need is a balloon. Not the kind of balloon we're used to being around at things like parties, where you're surrounded by pizza, burgers and bread buns, hot dogs and bread buns, and cake. I think bread might have too strong of a hold on me. Anyway, the kind of balloon we need is a weather balloon. A weather balloon is explicitly designed to reach high altitudes of up to 24 miles. It carries instruments beyond our atmosphere to send information on temperature, humidity, wind speed, and atmospheric pressure back to us. A French meteorologist, this guy, first started experimenting with them in 1896, and his work led to the discovery of the stratosphere. I wonder if he'd been proud of these balloons now operating as an extraterrestrial taxi service for our garlic bread. Maybe not, but I'm sure he'd be delighted knowing that hundreds of people worldwide today release these balloons for their own experiments every 12 hours. Most standard organizations believe that space officially starts at the completely arbitrated Kármán line, over 62 miles above us. Sending the bread into orbit would require a speed of tens of thousands of miles an hour. Without our rocket ship, which conventionally travels at a speed of 17,000 miles per hour, we won't be able to get the bread that high or to travel at that speed. Okay, no, you can still keep the rocket. I'm happy with my amazing weather balloon, which, by the way, will still get us a third of the way to space, bringing us to the area known as the edge of space. Given that the atmosphere up there is so thin, about 1% of the pressure at ground level, it's really not that bad of a substitute for actual space for this test. I was never comfortable with being over 62 miles away from my dinner anyway, so this works much better for my food abandonment issues. Ow, my ears! I can already hear you at your computer screaming, "What is this guy talking about?" I've seen videos of things like pizza being sent to actual space before, using a similar method. Why should we settle for the edge of space? Well, many cameras operating in those videos to document the object's journey use a fisheye lens. This lens exaggerates the Earth's curve compared to what it looks like at those heights, giving off the illusion that the camera is closer to space than it is. Glad we settled that. Unlike if I were to ask you which is better, pizza or garlic bread. Moving swiftly along, thank you. Now that we've got our weather balloon, to which we've reluctantly attached our garlic bread, the moment for takeoff has arrived. We launch the garlic bread to the sky and wipe the tears from our cheeks as we watch it disappear beyond the clouds. In comparison to a rocket, the pace of our balloon may as well be that of a tortoise, and it will travel at a speed of over 1,000 feet per minute. So, a good way to distract ourselves from the sadness of our bread's departure is by asking ourselves what the garlic bread's in store for during its journey. Well, in 2 hours, our weather balloon can rise above the clouds higher than the paths of jet planes, passing through the ozone layer in the stratosphere and reaching altitudes of 22 miles or higher. The balloon will endure temperatures as cold as minus 90 degrees centigrade, meaning we'd better have a microwave on hand should it make its way back to us. The balloon will expand as it ascends, from 6.5 feet up to 26 feet, because air pressure decreases as the balloon climbs higher in the atmosphere. What happens next would be a truly satisfying experience, were my food not being put at risk as a result. Our weather balloon pops. And just like that, our garlic bread will begin the descent from the skies. Wind conditions dictate how far from the launch site the bread will land, but we can expect it to turn up no more than 75 miles away. As is the case for experiments with weather balloons, a parachute is attached to the cargo, which will help ensure the bread's safe return and a reunion with its best friend, my stomach. Some say it's a one-sided friendship. Even though it's this stomach of mine that's currently making animal noises from starvation. It's actual animals who now pose a threat as potential predators of snatching our dinner. Engineers have designed packaging for exercises like this, equipped with GPS and a servo. This packaging will close shut approximately 3,280 feet above the ground. It will protect the garlic bread from unwanted landing spots and the various jaws of the animal kingdom, dramatically increasing the likelihood of being able to eat the garlic bread if we can relocate it. In all actuality, weather balloons used for experiments like this are doing more damage to wildlife and nature than vice versa. Marine animals like turtles often mistake the remains of weather balloons in the water for jellyfish and eat them, thinking that they've just got themselves an easy meal. This is damaging for these animals, given the components of these weather balloons contain rubber and battery acid. Arguments have been put forth that weather balloon testing is ultimately another form of littering. If this video inspires you to try and send some food to space using balloons, keep this in mind. So, the hunt is now on, not for any wild animals, but ourselves. What's that saying though? Fail to prepare, prepare to go without that fantastic piece of garlic bread that you've just launched into the edge of space, which you're now on your way to reclaim? Or is it just preparing to fail? It doesn't matter, as suggested by the parachute and protective packaging. We're doing neither. To ensure we could find the bread once it landed, we attach radio trackers to the balloon before launching it. These send a signal with a GPS position to the ground, which is then put on a map for us to chase, giving us a good idea of where the garlic bread will be found. Man, I love technology. And just like that, the moment has arrived. We've found our garlic bread intact. And after some moments of passionate hugging and loving strokes, I'm ready to take a bite. So, was the wait worth it? How's it taste? And can you eat it? Yes, you can. But the taste? Not that great, actually. And despite mentioning it earlier, I forgot to bring my microwave. The bread's been frozen from the frightening temperatures experienced on its journey. And I actually mean frozen. The bread itself has an icy middle. But before we can even discover this, we'll notice that when we go to rip a piece of the bread off, it doesn't tear as normal. Instead, it snaps off, as if we've just broken a piece off a twig. We can even hear the clicking noise. My warm, soft bread is no more. You'd be better off keeping this for dessert in the event you run out of frozen ice cream. On second thought, let's just throw it in the trash. Nonetheless, it's pretty cool that we were able to send this garlic bread to the edge of space and still end up eating it, right? Before I pass out from starvation, I'm going to the store to buy some more, which I definitely won't be sending to space. Why don't you let us know in the comments if there's any food you'd like to send to space for seasoning before eating?